Right, this is, now that it is daytime, Advent of Code Day 23B. So I've done a little bit of profiling, and I've verified that I am spending a lot of time in the memory equality comparison, the memory hash comparisons, because I am currently stuffing in the entire set of 5 by 13, soon to be 5 by 15 grid, or sorry, 7 by 13 grid, and that is taking up way too much space. A thing that I could potentially do here is to shrink this to I could shrink this to a, instead of an int, a, whatchamacallit, a byte, but that's still going to be quite large, in my opinion. So, instead of doing that, what we're going to do is we are going to eliminate a lot of the waste in here. Basically, what I want to do now is I want to, what we're going to do is we're going to define a, going to swap this out. So so this is just going to be a uint8, something like that, and then we're going to have a board, which is a map from chord to bool. And then that will never get updated. That only has to be touched once. So in fact, I'm not going to call this contents. I'm going to call this a you know what? LA ragged on me for calling them tokens like they're D&D characters. Like, let's call this. Let's actually give it the flavor it deserves. Let's call them amphipods. Okay. So that still is fine like that. Now is token is always going to return true. Okay, so now what we're going to do here is we are going to, oh, whoops, I forgot to plug that I was doing this on Twitter. Let me go do that real fast. Streaming my day 23B solve now. All right. So actually, what we're going to do is this. And then we're also going to do this. And we're also going to do okay. Okay, that seems reasonable. Those should no longer be possible, but that's fine. Right, so we're going to change this. So a world, instead of having tiles, we'll just have all right, and then finally this I'm going to take up to 12 amphipods. But I'm going to give them an NDEF. That way I can, for the part A, I can leave I can leave the last 4 of them blank and it'll be fine. Okay, so I'm going to leave this be for now. I'm going to change this logic later. This is going to be an incremental refactor. So now I need to change this. Okay. Something like that's going to do the trick. So now we don't bother setting this tiles map. Instead, this doesn't need to actually do anything. Both of these two cases are just a fall through. This one is terrain chord RC. It's true. And now we don't need to define this. Actually, what we're going to do is we're going to do this. Okay. And how cold is it in Canada? Well, I mean, actually, I can't show you out my window without doxing myself, but it's actually pretty sunny right now. But I'm indoors; it's warm, so yeah. And if we get here. All right. I think that should do it. So now A star needs to also take terrain. Okay, so now allowed movements needs to also take a terrain. Now I can put this logic in here. Actually, I'm going to change what I name them versus the variable. So let's call this type terrain. And yes, I've seen Babby, which actually Anthony Writes Code, who is one of my fellow Advent of Code streamers. I know about it because I've watched him use it. Yes, at the moment I use Nano. So we're going to replace terrain passable with passable terrain. And then down here, we're going to change this to that'll make it clearer. And then finally, that. Okay. So it's not passable, we return false. Otherwise, oh, hello, Anthony Writes Code. Thank you for stopping by. It's good to actually have you watching the stream as opposed to being busy yourself. So what we're doing here is we're just refactoring my solution of 23A to make it more quick, and then solving 23B is going to be really fast after that. I just knew that if my 23A solution was, taking something like 5 gigs of RAM and was taking like 60 to 90 seconds to run, it was not going to cut it for part B. The core algorithm is sound, so so each piece has a loc. Okay, so now I need to replace .tiles index with .passable that's not quite correct. We'll deal with that in a second. Okay. There we go. All right, so now we just need to go and fix up all this syntax. Yeah, I'm aiming for a completion time of less than 10 seconds in part A and less than 30 seconds in part B. That's kind of what I'm aiming for. Right. Okay. So this is... No, instead of passing a chord, I'm going to pass a... I'm actually going to pass a piece. Yours takes 5 seconds on each part. Yeah, mine will probably... I think I can probably get part A to less than 5 seconds. I'm just being pessimistic. Wait, that's wrong. We're going to return a... amphipod. Okay. Polymorphism, it's awesome. Or not polymorphism, like overriding functions to return multiple types. All right. Just do it. I'm going to refactor this as well. Because I think that makes this code a little bit more readable. Okay. So that bit of the refactor is done. Here we have to do something different. That's just going to return the piece itself. Okay. 3579. Okay. All right, so now we're iterating over the pieces. Okay, that's still fine. Route clear. Okay, so this is all, this here gets replaced with okay, that's still good. This also takes a this is who am I loc R, who am I loc C. Okay, that I don't need anymore, that still works. If not passable, and now this check is done here. This is, I think I called it passable or contents. Yeah, passable or contents. That takes row. Oh, there was an error in my original solution. That's exciting. Chord row, comma, destination column. Okay. That's good. Okay. I know I'm going to have to rework this when I need to squish down further than just going down 3. But we'll see. Okay. That looks good. That looks good. Yep, that's fine now. Has reached destination. Where's has reached destination defined? Okay, so that takes the amphipod itself, not its location. Similarly, and that instead of returning a set of coordinates, it's going to return already prepared amphipods for us. That way, over here, that doesn't need to be there anymore. This just needs to be after pieces I equals dest. Yep. Okay, and kind is just, instead of kind, this is source.movement cost. All right, so instead of this, this is just going to be w.type, so I don't need to change as much code. Actually, no. This is just the piece itself now, which is kind of nice, except for this is R is P loc R, C is P loc C. R, and C. Okay. The other thing is to make sure that I am dealing with this correctly. I'm going to also need to anytime I'm iterating over the pieces, I actually need something to generate all of the pieces. So that'll take care of filtering part A from part B. That way I don't have to write special cases. No. Yes, 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 yes. Okay. Now I've got a bunch of compile errors, line 37. What's wrong with that? Oh, that's the wrong kind of brace. Line 119 is seriously wrong. What's wrong there? Suborder contents. Oh, missing a closed brace there. 174 is wrong. Not passable. Where did I define passable? That returns a bool. Oh, because it takes not. It needs to take the terrain as well. Okay. Line 174 is wrong. Why is that wrong? That should work fine. This is the Go syntax for defining a thing and then testing a condition on it. Okay, if I ignore that for now, let's look at line 189 at least. Oh, it also does not like that. What have I done wrong? Like, do I need this? Is that the problem? Okay. Apparently you're allowed to do that in general, just not inside of the if statement, which makes sense. Okay. Alright, now we've got lots of fun stuff. called? Range pieces. What's that like? Oh. This is not a pieces, this is an amphipod list. 13, I need to pass in eight. Generates a list of amphipods. Oh, I've reversed my arguments. Okay. There we go. Getting there. Empty is declared but not used. Yeah, I don't care whether it's empty. All that I care is that if it's not empty, if it exists, then, yep, okay. 2, that needs to take a passable. Oh. You know what? This code reads easier this way. Compiler's smart. It'll figure out to inline that. That's not a problem. Source loc r. Almost there. All right, let's see whether I still get the same answer as for part as before. Having spent 45 minutes refactoring, I swear it's time well spent. And hopefully we should see a lot less memory consumption too. That'll be nice. In theory, that should result in a lot less thrashing in here. And this should run significantly faster, but we'll find out. We'll find out. While I'm here, let's take out, did I take out the comments I put in my world class? Yeah, I did. Great. It hasn't terminated yet. That's a little concerning, but it's not actually sucked up that much memory yet, so. Yeah, we'll see. Let's see what it does. think the reason why A9's code runs faster than mine is because I'm moving the pieces one step at a time, whereas A9 is just immediately short-circuiting them to possible places that they could wind up. 10, 5, 26. Is that correct? Yes, it is. Great. Okay, so I didn't break anything when I refactored. Okay, let's commit this refactor first. And let's also... let's see how bad we're looking now. Where am I spending my time? Still spending my time in here. Yeah, it's doing that stupid, stupid map access. Why is that so expensive? Yeah, I'm only spending like 7% of my time actually generating moves and evaluating the board. Like most of this time is being spent in here. Okay. So my world object, which I'm passing around in my heap queue, the world object contains a array 12 list of amphipods. Is it 12 actually, or is it 16? Shit, it's 16, not 12. That's going to make this problem worse, not better, but okay. La la la. And a given amphipod has a type and a location. So I was doing my damnedest to make this placeable inside of an array. Okay, well my swap method is a little wonky. Let's have a look at my swap method. So my swap method currently does this. Could make this faster by storing pointers to worlds rather than moving entire worlds around. But it doesn't fix that I have to be able to look up a given position inside of the map. Okay. I think I'll just leave this be. I don't think it's going to... hopefully it won't add too much state. Let's just add the part... let's add the parsing for part B. And then we'll see. Okay. So for part B, we want to add a couple of additional passable tiles. So this originally goes to 0, 1, 2, 3. Also insert. You can hear my spouse swearing at part B. She's cute. Like and appreciate my spouse very much. Just make sure that I'm not expected at any work meetings for the next hour. Nope, I am in the clear until 2 p.m. Great. Hope this doesn't take me until 2 p.m. So I am supposed to insert these. So if I is less than or or continue. Okay, so this looks like that in ASCII. So that's going to be this is going to be a ampersand type. Okay. DCBA. DBAC. Let's see, that will go in position 0, 1, 2, 3. That will be is that correct? 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3. Yeah, that's correct. Okay. So let's comment that out for now, because I only want to run the second part. And let's also, before we get here, we're going to print the current state of affairs. Uh, 353. Oh, it's not that chord, it's loc. Okay, so let's make sure that I've put them correctly. I've got a 3-3, 3-5, 3-7, 3-9, 4-3, 4-5, 4-7, 4-9. Then it picks up from here 5-3, 5-5, 5-7, 5-9. Yep, that's correct. Okay. Great. Let's see what happens. Oh, it's chewing through a little bit more RAM. Based off of how much bigger this number is, which is about 4-ish times bigger, I'm going to guess it's going to run about 4 times as long. So it's probably going to take... Oh, wait. No. Oh, God, I have a bug. There's another problem here, which is I haven't verified this. All of these things assume that there's only 2 things in the bucket underneath, but that's not actually true. Now I need... Now I need to change this. And I need to change this. Okay. So this passable think about the cases here. Not passable and contents is nil.
Oh.
What causes us to break out of this? This is not a return true, actually. This is just maybe a break here. Okay. So I think this removes the hard coding of 3. Is there any other place that has hard-coded 3 or 2? I think the only other place that's hard-coded, and I'm going to have to... I'm going to go back to my main function really quickly, because I do need to verify that I didn't break any functionality. Okay. Now over here, need to check this. If not empty and slot equals nil, I've hit the bottom and can break out to return our true. Yep, so that logic is basically the same logic as down here. We're just going to, instead of calling it slot, we're going to call it contents. Great. Okay, that looks fine now. All right, so did I remove my extra print line down here? No, not yet. Okay, great. All right, let's see what happens. How many people have solved so far? About half as many as solved yesterday. That's not too bad, not too bad. Feel pretty good if I solve this. I thought of a way that I can decrease my memory consumption here, which is I don't actually ever need to enumerate any of these maps. So I could write my own function to hash. I could write my own function to hash these things. And if I do write my own function to hash these things, then it will make it considerably cheaper to search through them. The only place where I need the full object, and even then I can use a pointer to the object, is in the work queue. Everything else is just doing a lookup to see whether I've seen the position before. In which case, I don't need the actual position, I just need the hash of the position and its score. This is actually a place where Zobrist hashes are very handy, because the Zobrist hash encodes this idea in it of being able to 10,526. Does that still match? 10,526. Yes, it does. Okay, so now it's on part B. So about 12 gigs and rising, but that's fine. Yeah, okay. I am at least moderately confident that this is going to finish and give me the answer that I need, and we'll find out. I guess I could also, especially given that I've got plenty of memory, given that I've got plenty of spare cores, I could also set this running at the same time without interfering with itself on the other day, on the simple problem. Like if I did that, I bet it'll return pretty fast. Plenty of cores. Yes, pprof points out weird tricks. Wish I had a better idea of progress, so that would sure be nice. Oh no, I'm trampling my pprof file. Yeah, not copying world state when you don't need to is faster. But on the other hand, my world state is much, much smaller than it used to be. So, you know, it'll be fine. It'll be fine. Oh, I guess the other thing I could have done is I could have recognized that these coordinates are tiny. Oh god, it's not even finished with that simple case. Yeah, I'm going to change coordinate here from movement cost is fine. Shouldn't column. Yeah, the problem is I'd have to change all of these. String grid to string transforms, yeah. All right. So this is uint 8. So I'll change chord here to also be uint 8. Change this here to be int 8. So let's just change all of these to be int 8. That's fine. Let's see what happens when I try to compile this now. Wait. No, because I need to look those up later. going to make these smaller. How am I doing on RAM? Am I going to my machine? I'll be fine. Okay. La la la. Okay, getting there. Yeah, those types sometimes annoy me. Oh, I see the problem. Spit out an answer yet? No, that is most unfortunate. Okay. And just one more problem left. Oh, wait. I have a critical bug. This is wrong here. C plus equals 2. Okay, that is allowing way too many things to go wrong. Great. I was wondering why it was taking so long, and the answer is because I've allowed you to move on the lower level too, which should not be allowed. And that was allowing too many n-constrained solutions. Okay, bugs. We catch them. That's fine. Alright, so... I'm sure this returns reasonably quickly. I think it will. Now let's go ahead and run it on my main input. What is my remaining diff? go ahead and push that safely to GitHub, and let's see how I run on my full input now. Yep, still get my full input, and relatively quickly. In fact, it's a little bit faster now. So now there are fewer options for what can move where. Should make life easier. Let's check. Let's check the code. Guess the one obvious simplification that I can make is if something was locked in place before and is now being moved directly to its destination, I think at that point I can short circuit a lot of this and just move it directly to the destination, compute the cost rather than going one step at a time. I think that's the main optimization I could make here. But I guess we'll see. We'll see. The other thing that I'm thinking about is the state of who has the hallway pass is technically something that I could probably exclude from the map. But I can only handle that if I'm moving pieces directly to their destination instead of moving them one at a time. Which I'm a little reluctant to do. Right, I think I might leave this running a bit, knowing that it, barring any logic bugs, will probably get me the answer, and I should probably get back to work. So you may or may not see me getting to actually enter an answer on screen, but I'll definitely share on Twitter if I successfully manage to do that. So yeah, I think this is where I'm going to leave you all, and I will see you all in a bit. Yeah. Let's see whether anyone is currently doing advent of code. And if not, my good friend Tanya is streaming something, so we'll go check that out maybe. Advent of code. Oh, one person is 2 people, 3 people are streaming. Who's this person? Let's have a look at their stream. Ah, another Golang person. Great. Okay, let's go send the raid incoming. Cheers, folks.